Hi, this is Alex from devstories.eu, Mastering DeepChem, Episode 7 of 15. Real scientific data is wild, unbalanced, and spread across massive numerical ranges. If you feed those raw experimental values directly into a neural network, you are practically begging for non-convergent gradients during backpropagation. To fix this, you need to tame your distributions before they touch your model, and that is where DeepChem Transformers come in. When you hear the word transformer in modern machine learning, your mind likely jumps to attention mechanisms, large language models, or BERT. Forget all of that for this episode. In the DeepChem ecosystem, a transformer is simply a data preprocessing utility. It is not a neural network layer. It is an object that takes a dataset and modifies its features, labels, or weights to fit within the strict mathematical constraints of machine learning. Take a scenario where you are predicting experimental molecular solubility. Your raw training data might contain target values ranging from tiny negative numbers to tens of thousands. Neural network weights generally initialize as very small numbers. If your input features or target labels contain a value of 40,000, the resulting loss calculation generates a massive gradient. The network weights will swing wildly during the update step, failing to converge on a solution. You have to scale the data down. One way to handle this is the MinMaxTransformer. This utility scans your entire dataset, locates the absolute minimum and maximum values for your specified features or labels, and squashes the entire distribution into a strict 0 to 1 range. The lowest value becomes 0, the highest becomes 1, and everything else falls proportionally in between. You initialize the transformer by passing it your target dataset so it can compute those boundaries. Then you call its transform method, which outputs a fresh dataset with the newly scaled numbers. Now the gradients remain stable. Squashing data between 0 and 1 is not always ideal, particularly if your dataset contains massive outliers. An extreme outlier will force the rest of your normal data points to compress into a tiny, indistinguishable sliver of that 0 to 1 range. For this, you use the normalizationTransformer. Instead of enforcing hard boundaries, it shifts your entire distribution so the mean sits exactly at 0, and scales the spread so the standard deviation is 1. This centers your data perfectly, aligning it with the operational sweet spot of most neural network activation functions. Here's the key insight. Scaling input features is a one-way street, but transforming your labels creates a secondary problem. If your model trains on normalized solubility targets, its final predictions will also be normalized. A predicted value of 0.4 is mathematically correct, but practically useless to a chemist expecting a real-world measurement. DeepChem solves this by maintaining the state of the scaling metrics inside the transformer object. Once your model generates a normalized output, you pass that output into the untransform method of the exact same transformer. It reverses the arithmetic, mapping the scaled prediction directly back to its original scientific unit. Normalizing your data is not an optional optimization step in deep learning. It is a structural requirement for training stability. Thanks for listening. Happy coding, everyone.